What if I told you there's an invisible gas, one that's found in volcanoes and even inside our own bodies that's hiding a secret identity? One moment it's a pretty pungent gas, and the next, bam, with just a little bit of water, it transforms into a liquid powerhouse that can literally dissolve metal. Let's pull back the curtain on this amazing chemical. So today, we're diving into the fascinating double life of hydrogen chloride. We're going to follow its journey from being a simple gas to becoming one of the most important acids on the planet, hydrochloric acid. It's a story of chemical transformation that's honestly pretty mind-blowing. And really, this whole thing plays out like a tale of two identities. On one hand, you've got the gas, hydrogen chloride, or HCl. But then you've got its powerful alter ego, hydrochloric acid. And that's just the same gas dissolved in water. Same chemical, two totally, wildly different personalities. You know, figuring this stuff out was a real puzzle that took centuries to solve. It all started way back in the 1600s with alchemists calling it marine acid. But it wasn't until 1810 that the brilliant Humphrey Davy finally cracked the code, proving it was made of hydrogen and chlorine and giving it the name we still use today. And this isn't some rare, obscure chemical you'll only find in a lab. Nope. Hydrogen chloride gas is all around us, venting from volcanoes. And get this, in its acid form, it's the main ingredient in the gastric acid in our stomachs. Yeah, it's what's helping you digest your food right now. Okay, so how do you actually make pure hydrogen chloride gas when you need it? Well, let's step into the lab and check out the classic recipe. All right, so this is what the setup looks like. I know, it might seem a little complicated, but the whole process is actually beautifully logical. We're about to take some super common ingredients and, with a bit of heat and chemistry, cook up the gas we're looking for. Let's break it down. First, you just mix some ordinary rock salt with concentrated sulfuric acid. Then you heat it up, gently, and that gets the reaction going, producing our gas. It passes through a quick drying agent to purify it, and then you just collect the pure, dry hydrogen chloride gas. Simple as that. Now, I said heat it gently, and here's why. The temperature is absolutely critical. So why stay below 200 degrees Celsius? Well, if you crank up the heat, you end up with this hard, crusty salt that's a nightmare to clean, you waste a ton of fuel, and you could even crack your glassware. So yeah, keeping it cool is the secret to a clean, safe, and efficient process. Okay, so now we've got our pure, dry gas. But this is where things get really, really cool. This gas has a hidden talent, a kind of chemical superpower that's so extreme it lets us do one of the most dramatic experiments in chemistry. It's time for the fountain trick. Take a look at this number, 452. What do you think that represents? It's not a temperature, it's not a weight. This number right here is the key to hydrogen chloride's incredible transformation. Yep, that's it. An unbelievable 452 volumes of hydrogen chloride gas can dissolve in a single, one volume of water. Just think about that for a second. It's not just soluble, it's extremely soluble. And this one property is what sets the stage for its complete change of identity. And this leads us to the famous fountain experiment. Okay, so imagine you have a flask that's full of our dry HCl gas. You introduce a single drop of water from a tube at the bottom. Instantly, all that gas dissolves into that tiny drop. This creates a massive pressure drop, basically a partial vacuum inside the flask. And what happens next? The air pressure outside forces the water from the beaker below up the tube, creating this spectacular fountain inside the flask. It's just a beautiful, visual masterpiece of chemistry in action. But you see, that fountain, it's way more than just a cool party trick. It's the exact moment of transformation. Because when hydrogen chloride gas dissolves in water, it's no longer just a gas mixed in a liquid. It becomes something else entirely, hydrochloric acid. And wow, what a change it is. As a gas, HCl is a pretty stable molecule. It won't conduct electricity. But the second it hits water, it breaks apart into charged particles called ions. And these free-moving ions are what let it conduct electricity, turning that pungent gas into a powerful corrosive liquid. It's a complete personality shift, right down to the molecular level. You know, because the gas dissolves so ridiculously fast, you need a clever piece of equipment to make the acid safely. If you just stuck a straight tube into the water, the gas would get absorbed so quickly it would create a vacuum and suck the water right back up into your flask. That's called back suction, kind of like trying to drink a thick milkshake too fast. So this inverted funnel gives a ton of surface area for the gas to dissolve, but it also creates an air gap that breaks the suction if the water level rises too high. Pretty smart, right? So what's this new alter ego really like? Well, hydrochloric acid is all about power. It's corrosive, it can cause blisters on your skin, it has a really sharp, sour taste, and it loves to attack active metals like zinc or magnesium, bubbling away as it reacts with them to release hydrogen gas. It is a chemical force you have to respect. But believe it or not, the story gets even more intense. Hydrochloric acid's power reaches its absolute peak when it teams up with another acid. Together, they form a legendary mixture, one that earned a name truly worthy of its power. Let me introduce you to aqua regia, which literally means royal water. The alchemists called it that because it could do something no single acid could pull off. It could dissolve the so-called royal metals, like gold and platinum. And hydrochloric acid is a star player in this regal recipe. And this right here is the chemistry behind the magic. You mix 1 part nitric acid with 3 parts hydrochloric acid, and this combination can do the impossible. It attacks solid gold and dissolves it. Basically, the 2 acids work as a team. It's like a 1-2 punch, where one acid pries the gold atoms loose, and the other one immediately grabs them and carries them away. It's the ultimate display of this chemical's unlocked power. So why does any of this matter? Well, because this powerful acid is an absolute industrial titan. It's used to make everything from dyes and paints to pharmaceuticals. It's essential for cleaning steel in a process called pickling. It's even used to make glucose from starch and to tan leather. Our modern world pretty much runs on this stuff. So there you have it. The journey of hydrogen chloride is, well, it's incredible. It starts off as this simple, invisible gas. You add a little water, and it transforms into an industrial workhorse that's so powerful it can conquer the king of all metals. It really is like a chemical superhero with a secret identity. It really makes you wonder, doesn't it? I mean, if such a profound change can happen just by dissolving a gas in water, what other amazing transformations are hiding in the everyday substances all around us, just waiting for us to discover them?